We're given the graph of f of x below and asked to graph f inverse of x. If f of x is a one-to-one function whose ordered pairs are x comma y, then the inverse function f inverse of x is a set of ordered pairs y comma x. Which means to graph f inverse of x, we can find several points on the graph of f of x and then interchange the x and y values of the ordered pairs. The new points will be points on the graph of f inverse. It's also important to recognize the given function f of x is one-to-one, meaning it passes the horizontal line test, where a horizontal line never intersects the graph in more than one point. It does appear as if the graph becomes completely horizontal on the left, but this is actually not the case. It simply approaches the x-axis, but never actually touches it. This should remind us of our basic exponential growth function. Let's begin by determining several points on the graph of the given function, and then we'll determine the ordered pairs. Let's use the y-intercept. Let's use this point. It's best if we can use integer coordinates whenever possible. So let's use this point, and let's say this point. And let's also select this point here, even though the y-coordinate looks like it's going to be 1/2. And now let's list the ordered pairs. Working our way from left to right, we have -1, 1/2. We have 0, 1. We have 1, 2, followed by 2, 4, and then we have 3, 8. And now we're going to interchange the x and y values of these ordered pairs. The new ordered pairs will be points on the graph of f inverse of x. So if this point is -1, 1/2, the ordered pair for the point on the graph of the inverse function is 1/2, -1, which is here, followed by 1, 0, and then we have 2, 1, followed by 4, 2, and finally we have 8, 3. The graph of f inverse of x must pass through these 5 points, but also f of x and f inverse of x are reflections across y equals x. So let's also graph the line y equals x to make it easier to graph an accurate graph of f inverse of x. So again, f inverse of x is going to pass through these 5 points, but also notice f of x has a horizontal asymptote of y equals 0, which means the graph of f inverse of x is going to have a vertical asymptote at x equals 0, meaning the graph is going to approach the y-axis. So the graph of f inverse of x passes through these red points, and then it's going to approach but never touch the y-axis. Something like this. And notice if we reflect the graph of f of x across y equals x, it matches up perfectly with the graph of f inverse of x. I hope you found this helpful.